8.2 Properties of Parallelograms. So we're going to be talking about parallelograms, which you guys have dealt with in the past, right? Okay. So definition of a parallelogram. It is a quadrilateral. So quadrilateral means it has four sides in which both pairs of opposite sides are what? Parallel. Meaning, if I show that, I have like an arrow there. So since I did one there, I do two here and two here to show that the opposite two sides are parallel, but they're not all four parallel to the same. Opposite sides of a parallelogram theorem. If a quadrilateral is a parallelogram, so we're just taking this and putting it into the conditional if-then statement. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So what does it mean to be congruent? Yeah. So they're saying if a quadrilateral is a parallelogram, that means that this has to be congruent to this, and this has to be congruent to this. So they're telling me that it is parallelogram. That's what I can get from that. Opposite angles of a parallelogram. So if I know that a quadrilateral is a parallelogram, then its opposite angles are also congruent. So this guy would be equal to this guy, and this guy would be equal to this guy. How many degrees are in a parallelogram? 360. So if I think about this guy with this guy, the non-congruent angles, what would they always have to be equal to? 180. Because if these two plus these two add up to 360, those two would have to be 180 to make those two 180 to add to 360 together. Theorem 8.5, if a quadrilateral is a parallelogram, then its consecutive angles, this is what we just said. What's that math term that we learned this year, though? They are supplementary, meaning that they add up to 180, right? So consecutive. So like A and B are consecutive, B and D are consecutive, D and C are consecutive, and C and A are consecutive. So each one of those pairs adds up to 180. And then last one, if a quadrilateral is a parallelogram, then its diagonals bisect each other. What does it mean to bisect? Yep. Look at the length. Look at CB, that's a diagonal, and look at AD, that's a diagonal. Are they the same length? Look at them. Do they look like they're the same length, A to D and C to B? Measure it with your pencil real quick. See if it ends at the same spot. C to B will be longer. Anybody know the only time that they will be the same length? Or times. There's two times, actually. Square and rectangle. So if it's a square or a rectangle, then the diagonals will be congruent to one another. Okay, knowing that information, I want for you to do number 1, A and B real quick. Okay, on 1A, let's talk about C first. How am I going to solve for C? What's going to be true about this angle and this angle? They are what? Oh, sorry. C would be on sides. What's going to be true about this side and this side? They are congruent. So how do I set up an equation to solve for C? Awesome, thank you. So I'm going to add 13 to this side to give me 18. I'm going to subtract 4C on this side to give me 3C. So what does C equal, guys? 6. Could you then plug it back in to find the actual length if they wanted us to? Yeah. Okay. How do I find D? Yeah, because those two angles are congruent, right? They're both what kind of angles? What do they look like they are? Acute. They look acute. Do we always assume that they will be acute, though? Should I make that assumption? No, don't make that assumption. Could I plug 9 back in to see if they really are acute? And if you do plug it in, you'll see that they are acute. Okay, on B, which variable could I solve for first? T. How do I solve for T? Why could I not solve for V first? Yeah, right. Exactly. So T equals 9. Is that what you guys got? Perfect. Now what would I need to do to help solve for V? So what's 2 times 9 plus 5? So that length is 23. So 9V minus 13 has to equal how much then? At 23, right? I'm going to add 13, so I get 9V equals 36. So what does V equal? Awesome. Any questions on those guys? Number 2, go ahead and read it and try it. You have to draw a picture on this to make it work. In parallelogram W, X, Y, Z. So first thing that we need to know, you may draw this and it may not be to scale, and that's okay. But when you draw it, you have to name it the way that they name it. So it goes around in circles. W, then X, then Y to Z. So you must name it around in that circle. The measure of angle W is 50 more than X. So if I put, what should I put for angle X for its measurement? X. Then what would I put for W? Good. Sketch the described parallelogram, label the angles algebraically, and then solve for the measure of each angle. So how would I solve for X now? Good. Because those two angles will be supplementary. Subtract 50, so I get X equals 130. Divide by 2, X equals, how much is that, 65? So this would be 65 degrees. That would be 115, is that right? So I got lucky, and I drew it correctly, making my acute angle with my acute angle, and this is obtuse, right? All right, last one, guys. Solve for each of the missing angle measures below. So each one of them. Okay, what would E be? Oh, sorry, yes. Yes.
Why would, like, this might be a dumb question, but
No, you're
why
fine.
would you make it 2x instead of x squared whenever you're setting up the equation?
Oh, because I have one x here and one x here, and we're not multiplying them. If I was multiplying them, it would become x squared. But since I'm adding them, we have an x plus an x, or an apple plus an apple, so I have 2 apples. Okay, so number 3. Real quick, we should be able to know what angle E is. What would that angle be? Okay, so what would that make this angle in here? 63, because that has to be supplementary, right? So that makes this 63. Now, how many degrees are in a triangle?
180.
180. So if I cover up all this, I have a triangle right there. One is 80, one is 63. So if I do 180 minus 63, how many degrees are left for that angle down below? 37. Can I do the same thing up here for this triangle? So 23, 117, take that away from 180. What am I left with? 40. So this angle right here is 120. Do you guys see that? So how many degrees would have to be down here? If this angle up here is 120, this angle down here would have to be how much? 60. We already found the 37 from it. So how many degrees are left for this guy? 23. Oh, what do you guys notice? Okay, so this works all the time because we have parallel lines, right? Transversal. Alternate interior angles are congruent. So this is 23, this is 23. So real quick, what would this angle be? 37. That should also tell us these two angles really quick, or you could do the math and subtract from 180. But how many degrees is this guy right here? 80, because it's alternate interior to this guy. And how many degrees are down here? And each one of those angles will still add up to 180. Okay? Questions on that? Okay. Guys, those are all the notes I have, so you have a good 25 minutes to work on homework. What you don't finish is homework tonight and your homework tomorrow for Wednesday. What you need to do is you need to do the practice C for 8.2, and then there's 8.1 and 8.2 in Schoology. Okay? So those 3 things right now through Wednesday. I think I put a due date of the Schoology tomorrow at midnight for both of them, okay? Any questions?